Let's explore Karnaugh Maps, specifically focusing on simplification with 4 variables. Karnaugh Maps, often called K-maps, are a powerful tool for simplifying Boolean algebra expressions. Here is the basic structure of a 4-variable K-map. We have 4 variables, A, B, C, and D. Notice how the K-map is arranged in a grid. The rows represent the values of variables A and B, and the columns represent the values of variables C and D. The key thing to note is the order of the values. Instead of going in a straight binary sequence like 00011011, we use what's called gray code. The columns are labeled 00011110, and the rows are labeled the same way. Each cell in the K-map corresponds to a specific combination of the 4 input variables. The numbers inside the cells represents the equivalent decimal number. The key principle behind K-maps is gray code ordering. In gray code, adjacent cells differ by only 1 bit. Look at the 2-bit gray code sequence, 00011110. Notice that when you move from one code to the next, only 1 bit changes at a time. This ensures proper grouping for simplification, as it makes it easy to identify which variables are changing and which are staying the same. When simplifying a K-map, it's important to follow a few fundamental rules. First, you can only group adjacent ones. This means you can only group cells that are directly next to each other, either horizontally or vertically, but not diagonally. Groups must be rectangular, meaning you can only form groups that are squares or rectangles. No other shapes are allowed. You should always make the largest possible groups. This will lead to the simplest expression. Groups wrap around the edges. The top row is considered adjacent to the bottom row, and the leftmost column is considered adjacent to the rightmost column. Valid group sizes are always powers of 2, 1, 2, 4, and 8. Here's an example of simplifying a sum of products expression using a K-map. The original SOP expression is a prime B prime CD plus a prime B prime CD prime plus a prime B CD plus a prime B CD prime plus a B prime C prime D plus a B prime C prime D prime. After filling in the K-map and making the largest possible groups, the simplified expression becomes a prime C plus a B prime C prime. K-maps have a special property called wrapping. The top and bottom rows are considered adjacent, and the left and right columns are also considered adjacent. This means you can form groups that wrap around the edges of the map. For corners, form a valid group because all corners are mutually adjacent. You can think of the K-map as behaving like a torus, where opposite edges connect seamlessly. Sometimes certain input combinations don't matter, and we can mark them with an X in the K-map. These are called don't care conditions. You can treat them as either a 1 or a 0, whichever helps you form larger groups. Use X's to create larger groups for maximum simplification. The legend on the slide explains the symbols. A 1 means the cell must be included in a group. An X means it's a don't care and can be included or excluded. A 0 means the cell must be excluded from any group. Here is a systematic approach for simplifying K-maps. First, fill the K-map with the values from the truth table. Next, identify all the ones and don't cares. Form the largest possible groups, remembering to wrap around the edges and using the don't cares when appropriate. Cover all the ones with the minimum number of groups. Finally, write the simplified expression based on the groups you've formed. Some key tips to remember are to start with the largest groups first. Remember wrapping at the edges. Use don't care strategically and verify that all the ones are covered. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.